we move ahead to the next module of stationary waves. And students, in this module, we are going to study about the laws of vibrating string and the extension on the laws of vibrating string. We have already studied certain basic laws and the extension will be purely mathematical based on it. So let us start with it. We know that the linear density, that is small m, is given as mass per unit length. We know that mass is density into volume. So substituting that value over there will give me density into volume upon length. But we also know that volume is area into length. And I know that area is pi r square for the area of cross section. So can I say volume will become pi r square into L, and on substituting that I'll get rho pi r square L divided by L. Now when I see that equation, I get a tendency to cancel out L and L. On cancelling L and L, we get small m as rho pi r square. So can I say linear density will have a value rho pi r square. Now let us revise one important concept that we did earlier. According to the law of linear density, I know that n1 multiplied by root m1 is equal to n2 multiplied by root m2. Now according to this concept, if I substitute the value of small m, the relation will come out something like this. It will be n1 multiplied by root of rho 1 pi r1 square, which is equal to n2 multiplied by root of rho 2 pi r2 square. Now if the material of the string is same, that means rho 1 is equal to rho 2, which is equal to rho. So can I say rho and rho will get cancelled and pi will also get cancelled. I know that r1 square is the only thing that is left under root and r2 square is the only thing that is left under root. So can I say square and square root will also get cancelled. The final answer will be n1 r1, which is equal to n2 r2. I know that n is inversely proportional to r, so frequency is inversely proportional to the radius. Now, this was the general equation that we had. So on keeping this general equation aside, let me now consider that if the material of string is different, that means the densities are not going to be same. So rho 1 will be not equal to rho 2. Now I know that rho 1 is not equal to rho 2, but pi and pi are still the same, so pi and pi will get cancelled. So I get the following relation: n1 multiplied by root of rho 1 multiplied by r1 square, which is equal to n2 under root of rho 2 r2 square. But I know if I take a condition that if both the radius are same, then can I say r1 and r2 both will get cancelled. So this will come out to be n1 under root of rho 1, which is equal to n2 under root of rho 2, which is constant. So can I say frequency is inversely proportional to square root of density. And this is also one of the most important mathematical relation that we need to remember while solving problems. So we studied two relations, that n is inversely proportional to r and n is inversely proportional to square root of density. Moving ahead to the next concept, the concept of specific gravity or relative density. It is defined as the ratio of density of substance to the density of water. That means sigma is rho divided by rho w. I know that density can be written as mass per unit volume, and density of water in this case is mass of water divided by volume of water. But since it is in multiplication, it will be reciprocal. That is why it is volume of water divided by mass of water. Now let me consider a case in which if the volume of the substance is equal to the volume of water, so can I say both the volume will get cancelled. So sigma, that is the relative density, will come out to be mass of the substance divided by mass of equal volume of water. And one more way of defining the relative density is the ratio of weight in air to the loss of weight of a body in water. So can I say sigma will be weight of body in air and divided by loss. Now loss is written as weight of body in air minus the weight of body in